doesn't help you guys out necessarily. Yeah, I hope so. Yes, yes, definitely. I mean, yeah, recording these is critical. So, yeah, all right. I'll get myself set up and then we'll blast your guys' screens here. Yeah, I haven't built the other seal plate assembly yet either. So, let's see here. I'm going to pick up where we left off though, which is in this. I had you install this gearbox on it on the pretty much the master assembly here, and so I'm going to swap this thing out. So let me send my screen to your guys' screen. I uploaded just a new model for this gearbox in the screw conveyor resources. So I should have swapped it out. It has just a different name, just has a number two at the end of it. And so you can download that. It should be in Canvas. I should have a Canvas screen somewhere. Yeah. So my screw conveyor resources, I've got a new one. So just go ahead and download this new drive gearbox and motor model. Sue gear motor number two. Yeah, this is the one I'm going to download here. So download that and move it to your, yeah, just save that one in your parts one. You'll have a kind of a duplicate one, but it has a different name, so it should be fine. And so when you get that downloaded and moved into your parts, I'm opening this assembly where we installed it. It's the only assembly I have open right now. I just want to show you how to swap that out. So mine is in, I'll open up mine. Mine's in my parts folder. I've got my two. This is number two. Should look like this. Littler die with a big old motor on it. Um, just I'm gonna skip like how to pick this thing out. It falls into the engineering side of things for sure. Um, I'll just take a quick note to say I did kind of post some of the stuff that an engineer might or would probably use, and what they would need to know is let me see. I'm gonna open up one more document. My SEMA kind of conveyor manual that I'm using real quick, and I'll just discuss this for information only, but it would kind of be a deep dive study, and I don't think we don't need to go into that for our situation here. But if I did look at the resources we're using for this, oh yeah, this one, just my guidelines that I'm using. What the engineer is going to have to consider when they pick a gearbox and a motor, they're really going to need to come up with like a gear ratio that works and how full this thing needs to be. And I just wanted to show you on this. This capacity charts becomes pretty critical in picking your gear and your drive because generally screw conveyors you're not going to load them full. I mean, they can be loaded full, but these would be best circumstances is how these are loading. And of course, you'd have to identify the material that you're using. It's kind of its density and and so you would categorize your materials, which I have on this other sheet that we've used as well. Sorry, I'll open it up. Maybe I actually already have it open right here. This is my kind of my engineering conveyor notes, and they're going to be dealing with like how many pounds how many pounds an hour need to go through this, and then the density of that material, and they're going to come up and classify all that. Then they're going to maybe use a resource such as this once they've identified it, and they need to consider how full they're going to fill this thing. Which this shows you that we're in the 45% would be up to the center pipe if I had this conveyor loaded, and down below that. So obviously, the more load I have in here, the little harder it is on my gearbox and drive, and the lighter the load, the kind of the easier that is. So then they would go through and they would figure, okay, well, this is my load. How fast do I have to drive this thing to push 9,000 to 12,000 pounds through it an hour? And they would need to come up with a gear ratio. And so, engineers might develop something like this, which I have also uploaded. Let me go to my real quick. The drive motor calculation sheet that I have here is just an Excel spreadsheet, and an engineer might develop something like this so that they can input some of the parameters that they're looking for, the capacity, its bulk density, and then how fast they need to push that through there and how many pounds they're filling and come up with a gear ratio. So this is just kind of a calculator sheet that you can test out some different gear ratios once you've put in the other parameters. And this is going to tell you over here how fast, what the percentage full of my conveyor will be. And that's what's going on this. And I've actually uploaded it for about I can't remember if I pulled a different gear ratio today. I kind of think I did. And so I think my gear ratio is only like 22 to 1 on that gearbox we just loaded. So what it means is I don't have to kind of turn it as fast to get that 9 to 12,000 pounds through it. I mean, we might actually be able to have this stuff in here a minute, I don't know, to 0.5. But I would like to see like what my gear ratio is and how full my conveyor is going to be. And I would be targeting kind of like that manual shows, maybe less than 45% for sure, and maybe in this range, depending on my material classification. But this is all a big kind of deep dive study. This is where your engineers are going to help you out with this stuff. Maybe develop a calculator sheet. It wouldn't be expected of a drafter to necessarily jump into that. Maybe a designer would become more familiar. In my experience, it was sometimes engineers had developed the calculation sheets and then they would deliver them to me as a designer and say, hey, just use this as part of your design process. It was my responsibility to order the gearboxes. They had built the calculator to define what that is, and I'd be working with sales from how the conveyor was sold. It needs to handle this many pounds per hour, and so we would, yeah, some of those calculation processes would be built by kind of sales, project engineers, project managers, and then they would be delivered to us to maybe just use. It might be my job to, yeah, source that gearbox, get it ordered as soon as I can. Yeah, so I just wanted to point this out that if you're interested, you can dig through some of the stuff that I have posted, and uh, and that's what this is all about here. So, long story short, what I was mainly concerned about on if you've got this open now, is just that I was going to drive it with the correct kind of shaft and the correct kind of drive instead of a keyed drive. And it's okay if you did that on that other one. I don't, because you could suppress those features if you've cut a key in yours for that other, and because that is a good exercise. There are a lot of gearboxes that you will key and we'll go through uh, that whole process of picking the right key size. And generally, this model has been downloaded from the manufacturer, so they're pretty good. It's interesting, they don't give you, and this is kind of how you share information. What I want to show really quick too is that, when you download stuff from manufacturers, if I section through this thing and just pick some plane to section this, it gives me the data I need to work with as far as like aligning it and how big it is to fit my shaft, but it doesn't give me any of their details of how. I mean, I'm not seeing any internal components of this gearbox because it would be all these gearing going on in here, this motor, and there would be oil levels in here. So this is a really simplified, only for what I needed. They don't want to give me their proprietary information. When we share models with people like that maybe just we sometimes just count like and there's a way to export models from Inventor that are simplified and protecting proprietary information, but still give the end user that's going to want this the information they need to size it for their situation. So that's all this gearbox has. It's a really dumbed down model, but it gives me the size where it's going to fit in I get an overall feel of how big it is and how to mount it and how to put it on my drive shaft. So it contains the information I need. And so you'll do this a lot if you're in an inventor type situation where this is how you model and people need to see your models to use them in a space somewhere to work off them. Yeah, you send them simplified stuff and you simplify the model. Um, so that's a whole step in here. Let me see where that would be. And for people that want to I'm not going to do this much with you on the simplification of stuff, but let me go to this thing. And oh yeah, right here. It'd be on your assemble tab right here. Simplification is and it's just a big dialog box that I can go through and pick parameters to decide what stays and what doesn't in my assembly, or whether I'm just kind of sending them a whole solid that just gives the size representation. But this command right here simplifies how I would dumb that down to be protecting proprietary information, but delivering someone information they can work from, just like that gearbox has been delivered to us. So a couple of notes there that are we're not going to explore deeply, but they're in here. The moral of the story will be by the end of next week is we've only scratched the surface of the capability of Inventor. It's a deep dive, and so there's a lot of your personal homework you can do for sure. Let's see. So what I want to do is swap this thing out. So here's another just kind of quick way the inventor can do this. And so I have the old gearbox in that I don't want. And so I'm going to swap this thing out. So if I just select this, I don't know where this stuff is on the ribbon menu. I've never dug through to find what I'm going to do here, but it's just on a right click menu when I have this, which you get it. I mean, this is a master menu for sure, but on component right here, component replace is what I want to do. I want to replace this component. So this is component replace. If you have a bunch of these in the assembly, you can replace all. If this is, this is how I would do stuff when I'm like, oh, I've made a design change, but I want to kind of work with what I've got rather than just delete it out. And sometimes this works great. Sometimes you still end up having to massage it to work. So if I say replace, it's going to drive me into pick what you want to replace it with. And I'm going to say I wanted that gear motor 2, and I'll just say open that. It'll say maybe there's some stuff that's going to be lost here, mostly constraints likely. So I'll say okay. It'll maybe give you this error. Hopefully it'll say accept that, and it will replace that component with the next one. And then I've just got to just pay attention to my constraints. So they don't obviously blow up on my model browser, but on this relationships where I am constraining stuff, if you see the show sick show up and go, if everything is happy in this assembly, that show sick will be grayed out, like there's nothing wrong with it. So if you ever just pay attention to this on occasion, this will let you know that you've got issues and that you necessarily aren't picking up on the browser here. So if you ever see this light up, say show sick, and it'll bring up the imagery for the constraint that is not happy. This one here is not happy. And the main reason is because it just doesn't have the same features of the last gearbox. So it kind of lost. That was my insert constraint that's blown up on me. All it needs me to do is repick some geometry of how this works. So I show sick, I get the icon to show up. I right click this thing and I can edit it. I mean, you can delete it too and just start it fresh. If you edit it, you might have an idea of where it looks like selection 1. I had picked the bearing face edge, which within the insert command, it's picking a face and an edge with an axial alignment. So it's kind of compound constraint here. And I need to pick the next one. So I'm going to say it's this one on the most protruding feature, which this is actually part of this actually slips on the shaft first, and then the gearbox slips onto that. And then this thing actually has like a bunch of bolts that torque it down tight to this shaft. It's called a torque lock. And so it prevents you from having to cut keys, and it's a shaft mount. So they're kind of a nice clean assembly and maybe easier machining is one reason. Some manufacturers might like them because it is a torque lock, so it could slip on the shaft. I mean, it's designed not to, as long as we're using the gearbox and torque lock how it's designed. But anyway, so I'm going to say it's this outside edge here, and that's just going to be that inch offset that I put between the bearing and where my gearbox kind of starts. I'll leave it as an inch right now, and that should be the only one that's not happy with me. It's still the plane alignment. And then once these things are happy, they settle down. But you can just say hide all again now. So yeah, now my show sick is not active. So that's a little fix. What's that? Yeah. So then I'm gonna cut a section and take a look at how it fits on the drive shaft here. So I'm just gonna cut my section, half section view, any place you could pick a plane or whatever. I want to cut it this way though, kind of across into it this way. And I'm just gonna peel it back. I'm just peeling it back by view here. Yeah. On the back side of here too, this is actually part of the torque lock assembly right here. So I've got this little part that kind of slips in. The gearbox kind of slips onto that torque lock, and then And then this one gets attached to the kind of the other end of the gearbox. And this is another, it cinches it down on this end as well. And then this is just a cap over those components here. Just kind of a bolt-on cap, like a dust protector, dust and water. So yeah, this is what I was kind of expecting. I must not have paid attention when I downloaded that other gearbox. I kind of configured it wrong and maybe configured it a little bit large. And so I'm just gonna say I just cut this section view. I mean, I could say, yeah, that's good. It's cut it into where I can say I'm gonna leave it for a minute. I just want to get this measurement. I want to know how far this shaft goes from kind of right here, this face, not the outside dust seal face, but right here, this face of that torque lock to the end of my shaft is a dimension I'm looking for because I need my shaft to span completely through this gearbox to where it at least comes to the end here. And maybe I'm going to say it's going to protrude about an eighth of an inch through there and put a little chamfer on the end of my, I think we've already put a chamfer on the end of the shaft. So really, I just might want it to be this dimension. Yours could be slightly different than mine, but I would just pull the dimension you have here because mine's an inch away from the bearing. And I'm showing up that I need to add 2.2195 or 6.2195 to my drive shaft. So 6.2195 would be what would get me right to the end of that torque lock. And I'm just going to add an eighth of an inch to that. So it just goes proud through the torque lock just a little bit. So I just need to add 0.125 to whatever dimension you've got there. If yours is the same, then you're right on target with me. If it's a little bit different, I wouldn't worry too much until we find out why that is, maybe. Then we'll worry. But I'm going to add this much to my shaft. 6.3445. So now I'm going to drive down to that assembly and do that last modification to the drive shaft. Yeah. So from here, I can say I'm done measuring. I've got my dimension in my calculator to use. Yes. And I'll delete my section view now. Oh yeah, delete the so my section view is on the I use this a lot on the view tab and the section view in the visibility palette here. And this is I cut a lot of half section views when I'm checking fits. I use three-quarter and quarter section views less, but I mean I drive, I view my models a lot to check for fit up like this. And then once I'm done with it, sometimes I just do it to this point, but if I need to measure and work with it, I just check it so that it's active, it stays there. And then to get rid of that view, though, is just in the menu, they have a delete section view. In the mechanical world, you get used to doing that a lot. You're always looking for fit up and the intricate details of how parts are working together. So, use that. I can cut section views. Just pick up, any face on your model, and you can cut a section view from that face. Uh, yeah. So I do that a lot. And then what I want to do is open up this assembly now. So I'll just open it up from this assembly. I'm going to open up the screw assembly right there. That's the one we need to get some prints going for, but I need to get this thing sized right. So I'm just going to say open up this now. And this is down to the model that had I don't need to turn this on, but this is the one that has the center pipe in it. And I just want to add that amount to that extrusion. So it's the extrusion that comes out from the center pipe. It was our first extrusion we did. I just need to edit the extrusion, edit feature. And it's originally we had it 11 and 0.75 following the manual. And now I realize that I've got to add that much to it. So I can actually, if I don't think I'd probably not do this one as an equation either. You could just add that value in and leave it in as an equation, but the 11.75 doesn't mean much to me at this point anymore. Yeah, it was just a baseline start. So I can really just come in my calculator and say, I'll add my 11.75. This should be the overall extrusion that would fit my gearbox now. Mine's 18.0945. So that's what I'm going to make this 18.0945. Yeah. Oh, yeah. Yeah, you've had a fillet that's failed. And then what? Oh, yeah, what was that dimension? 18 point, I think it's this one right here. 18.0945. I'll double check that I got mine right. 18.0945. Yeah. And then I'll just hop over to that main assembly here, this one, and I'll just hit the update flag here. Yeah. Yeah, when I did this extrusion, it's actually an asymmetrical extrusion, and so I'm driving it 4 3/4 into the pipe, and then I'm driving it the rest of the way out. So it is this asymmetric type extrusion that I used on that original. Yeah. Oh yeah, get you good, good. It's probably a cut. It's like a machining cut to it. Yeah. We have these cut extrusions after we did the full length. Yeah. Yeah, that's because the other two were the inside cut and the outside cut. Oh yeah, it might be. Oh yeah, if I did that extrusion and if I had done the cut, this is my third extrusion when I actually cut that surface. So if I go into that one, yeah, this one if you picked, I picked two when I did the cut down to 2 inches. I had picked two next kind of here, and then I actually had picked the face of the center pipe as where to end that cut. So if you had put a dimension in here, this is it's good to see that. It's not wrong to put dimensions in here. It's just you have to remember, oh, go into these other parts and do that. Um, Sometimes you'll notice my habit is when I do cuts, a lot of the times I don't try to establish cuts by length. I like to establish them by that way when I do stuff like this, it's like it automatically updates for me. But a lot of designers, you know, they think differently, and that's fine. And you would be like, I'll just put the actual dimension in, and then if I change that other length, then I got to come back in and change the length of the cut, and that's just another step. But sometimes I select this wrong too, and it blows up on me, and I'll be like, whoops, I didn't do my cuts right. Yeah. So sometimes I'll pick the wrong surfaces or something, but and that's what we wanted to get to. I'll go ahead and turn off the surface. I just turned it on for a minute just so we could see it, but that's the only real change I'm making to this. Yeah, where the shoulder, yeah. I would right here. Yep, yep. Yeah, you'll call this a shoulder for sure, just this step down shoulder here. And I did put a fillet in there. And it's an odd dimension too. It's like 0.0335. And that's just because that's right to the very edge of that, the difference in diameters. Uh, so this one I'm happy with. This one I jump back over to this assembly. I know I'm skipping this one. You can come to this one and update it as well. But this one will update downstream generally. So you can update this one here. And then now I'm going to cut that section view again, and I should see it come through. I guess I could have left my section view on here. That would have been good smart. But if I just cut a new one and yeah, and cut this in here. I just want to do a double check. I've planned on it coming through this about 1/8 of an inch here through the end of the torque lock. And I still have room between that and the dust cover that I'm not going to rub the dust cover with my shaft because that thing's going to be constantly turning. Yes. So that's cool. That's like a real simple, but it takes a lot of drive shaft to use these shaft mounted gearboxes. That's a pretty normal thing that normal guidelines would be for just a gear being added to it and not necessarily this big old thick gearbox. So, all right, that thing's going to do our turning if we secure it down, which we'll see if we may have to do that next week or something. We'll see how far we can get because I want to put the seal plate in there and then I want to do some hardware. and then we'll worry about locking this thing down. But kind of when I was looking at it, I was like, well, to lock that down, it might to me if I look at it this way, and you can do like I'm not going to be super critical on how you would lock this down, and I will do it probably next week just to because I'll have a hard time not locking that down and feeling like I've left off a major component, which is to secure that thing. But I might come in here and I might plan on like welding a part to this end plate, like maybe like a 3/8 inch thick piece of stainless steel that's just going to weld in here, and maybe it's going to be about the footprint of the bearing or so, six or at least 6 inches maybe right here of weld that I and it might just be a plate part that then just comes up and then comes maybe has a bend on it and then bends with a hole in it to accept this. So it could just be like a two bent part, and it might be wide here, and then it might kind of tape. This is hard to visualize. I get it, but it might be like wide here, and then when it gets to that first bend, it might kind of taper itself down to where when it does the second bend, it's only going to be about the diameter of this, where that plate reaches out and maybe matches this kind of profile and has that hole in it to accept a piece of hardware to bolt it on. So it would be just a torque arm, I guess. Maybe is that what they call it? Yeah. The mount, it's just definitely a mount for this. They will sell those too, the mounts from the gearbox manufacturers, and then you'd have to design around that a little bit. I can build my own bent plate part, and so I might spend some time on that next week just to secure that thing. I want to secure it to the kind of the heaviest piece of plate I have on. I wouldn't want to secure it to the 12 gauge. That's kind of flimsy material actually. So I'd want to secure this to kind of the heaviest, and 1/4 inch is the heaviest plate part I have. So um yeah. Then my end plate kind of becomes, yeah, and I would add that on as the latter part. Like they're not going to add that torque arm on until they've got all this up and they just are ready to secure it. And so sometimes our torque arms we make them a little bit big in the flat pattern. Like I know that I might perfectly theoretically get this the right length and it bends over and it kind of profiles down to match that profile. So to me, it's got kind of maybe a couple little 45-degree bends or something to get back to straight here. And then sometimes in the flat pattern, I'll add like I don't know, a 1/2 inch of material right here that may have to be cut off by the assembler, but it would just be a part that's long enough to do what they need to do, but it might have to be kind of a custom fit part. And you could make it bolt on to the end assembly as well. I mean, you can make it instead of welding to the plate, it could bolt through the plate. So there's a lot of different things you could anyway. There is, I could just tell you guys design something that would support that. Let me take a look at it. And you might design something that I want to use. So if you have time and you want to mess around with that, think of how to support that thing. Oh yeah, because I think this is an add-on too, and it is in my model that I'm adding on this like because you can buy these and not even have this part, and I could have said, don't supply me this, but the gear housing itself will have like some holes tapped that I could even build a different mount than even this that mounts right to the side, kind of like well, be like on the other side if I end my section view because I'm happy with that. No, I think it is designed to only have it on one side. This side. Some gearboxes, you have this side plus maybe this side that could be used as a mount. And in this particular gearbox that I've supplied us, it's only going to let us kind of put the assembly on this side. And I asked it while I configured it, yeah, give me a torque arm, and this is what they supplied me with, this little bolt-on part. So, but you can choose from the manufacturer, eliminate that, and I'll just do my own, or give me that, and I'll just design to this. So, yeah. Okay. And now this is where we're also installing the seal plates, right? Yeah, this is the assembly where the seal plate has gone in. What we did at the last um we made a copy of this part. I'll go ahead and open it up right now. This seal plate that we used on the driven end. I'll never get it right. Okay. Driven end. This is our assembly of that. We made a copy of the part though before we left last time. So if I open this, yeah, totally. So I'm going to open up the copy of this part that actually matches it right now. Because what I'm looking at in this assembly on the other end is, well, if I brought that part in, you would see it doesn't match this at all. So I don't have it in there to look, but it matches perfectly this bearing. It's not going to match the other bearing. So I'm just gonna close this. I'm just reminding you that I did make a copy of this. I have not made a copy of this assembly yet, and so um, I'll do that in in just a second. Yeah. So I'm gonna open up my copy of the seal plate part, and that's that one for me. So I have my first seal plate part was a few up from the O-rings. It was this one, SC020 for me. The one I made a copy of is SC024. So I'm going to open up this copied part. And then I'm going to go look at, I'm going to pull up my bearing information data sheet. So in my resources, I have the data sheet for the mounted roller bearing. Yes. And I'm gonna change the profile of that other seal plate to match this 5 5/8 with a 4 3/8 hole pattern. And the holes themselves are 1/2 inch holes. Because my seal plate kind of needs to match this. It'll slip over the hardware that we're going to add to the end plate here in just a minute. So with this in mind, 5 5/8 by 4 3/8 hole pattern, I'm going to come in here and change this to do that. It's probably going to be my face sketch is the main one. The first extrusion or sketch, I did a face sketch because I had a 1/2 inch plate sheet metal part. And I'm going to edit this one to match those dimensions, which I can't remember, but that's why I have this up. 5 5/8, 4 3/8. I'll try to remember now. Five. Yeah, I have driven dimensions in here, so I just need to change the one that's not a function dimension here. So this will be 5.625, 5 5/8. 0.625. 4 3/8 on the for for the whole pattern ends here. Yeah. Oh yeah, it's easy to yeah, 5.625 is the overall profile, and 4 3/8 is the whole pattern profile. So I've got that. The hole through the end plate stays the same, so I don't have to change that. That should be all I have to change, except for I'll just evaluate kind of the radius that's cut on them right here, because we have currently we have a radius that matched that other bearing. It was kind of an odd radius, 0.6374. That's just because it matched the driven bearing. So I'm gonna go check. I'm gonna check my data sheet. I don't really think it gives me a radius on that because it's kind of like a non-critical thing. But I'm gonna go check it on the modeled part of it, which is here in this assembly. Back over here, check that fillet radius, and I'll change mine. It's actually just kind of a better number, 0.625 to 5/8 radius. So I think I'll just do a slight change on this part here. What's that? Yeah, not much, right? Like it's just a small detail, but 0.625 is the radius there. And then all the machine work we did was the same. So it's gonna take the same oil seal and the same O-ring. Oh, it was my fillet. I had filleted these. You know, some people might fillet in the sketch, and that would be okay too. You'd fillet your sketch, and then that'll already be cut in it. That's, tomato, tomato, either way. I tend to sometimes I don't love sketches where I fillet them and they get kind of hard to manage once you've added a kind of a rectangular dimension like I have, and then I fillet that. I don't know. I use them and I'll do it, but sometimes I like to fillet it after I've done something like this. Seems easier for me to change, but not necessarily. Either way would be fine. All right. I just did mine as kind of a fillet feature, and this one is done. I'm gonna save that real quick. Oh, 0.625. Yeah, because it was a nice clean round number, 5/8 on that other bearing. And I think I'll just check my hole. Oh, we need to change the hole size. I forgot one more thing. Change the hole size. Yeah, because it's kind of a big. It needed a bigger mounting hardware on that other bearing. So I'll just. Yeah, to me it kind of is a little confusing because this is actually the heavier duty bearing and it actually has smaller mounting hardware, and that other one that's just a roller bearing is. And if I probably would have perused through hundreds and hundreds of bearings on McMaster car, I probably could have found one that had the same mounting hardware, but I didn't. I mean, I just kind of found one that looked like I probably perused kind of quickly, found one for the shaft size is the most critical, and I didn't really realize they weren't the same until I was like, oh, I guess they're. I should have dug a little deeper through McMaster car to see if there was a bearing that matched this bearing is what I'd like to match because this is the heavy duty bearing and it's actually smaller hardware, but it's going to be all I have to do is change it to a half inch hardware. That's not necessarily true. What I could change it to is 7/16 clearance hole for 7/16. Or I could just change this to just be a half inch through simple hole. Because if I think about this a little bit, I'm just going to try to match this size here. I don't know if that's what we did on our other bearing. I'll have to go back and look. If the two, if I match this size, it'll be like a nice consistent through hole through the bearing and then through the seal plate, and then and a half inch will still be big enough to bolt on 7/16 hardware that will still pass through it in clearance. So maybe I don't need the clearance hole half inch, and sometimes I change my mind when I get into these other little details pop into my mind sometimes from one day to the next day. But in this case, what I'm doing is, on that other plate we were doing for 5/8 hardware, we were doing a clearance hole. That's why this is kind of selected. If I decide that I want to match the bearing and the clearance is already in that, I could just say simple hole. And then it's just a matter of tell me the diameter of the hole then. It doesn't have all the hardware details that's going to go through it. So that's the difference here. Is this is the reason why I would use a clearance is because I'm going to specify the clearance I need for this particular fastener hardware. In this case, I'm like, well, I'm actually matching the bearing profile. So I'll say simple hole, but it needs to be a half inch. And I'll say okay. And now I will save this part. And then what I want is to have that, you should have, like I did, I came in here on this master assembly and I opened up this assembly right here. Open. And this is the one that I have open. This is the other one, the big one. I'm going to make a copy of this assembly, just like I did a copy of that part. So I'm going to say file, copy, save as a copy. I'm going to put it in my assemblies folder. It's just going to be my next assembly number. Mine's 1, 2, 3, 4. This is the fifth assembly we've done here. But really I'm SC, yeah, so it's actually SC00 or 04 for me. But whatever your next assembly number is, just save that. What's that? Yeah. Yeah, I'm going to save this one here. Yeah, it did duplicate it, but it doesn't open when you do that save copy as, it does save it and it's in that folder, but it doesn't open it up automatically. I'm going to go and open it now. And in order to like keep from confusion, here I'll stop sharing so you can get in there, Sky. Yeah, for a minute. But what I'm going to do is I'm going to close this one because I don't want to confuse it with the other one. There are modifications. Yeah, go ahead and save whatever it is that I modified on it. So all I've got is my seal plate that's the part that's open, and then I'll stop sharing. So you should be able to get in, Scott. Yeah. And I'm just going to go and open that assembly that I just saved a copy. That's this one. It's essentially just like the other one. I want to make it different now. I want to swap out this part with this part that I just made right here. Okay, cool. Yes. So my next. Oh, yeah, it's kind of annoying that mine will stay that way, but where your systems get rebooted, I feel like it never keeps those presets. Inventor's pretty good at like always remembering the last thing you use, kind of, and you almost don't have to like keep toggling that in. But I do think that is annoying that you have to always go in and like if you want to see the edges, which I have a hard time modeling without seeing the edges. Um, I'm gonna swap this part out like we did the gearbox though. Same step. I'm just gonna select it because this is an assembly, just like the gearbox was. Component replace. The only way you technically remember any of this is just the use of it. So you guys will always have access to my YouTube channel. And I'll always be there for you. Oh, really? Yeah, you guys might want to turn off your notifications next year when you'll keep getting my, my new uploads. But what I'm gonna do is replace this here, replace that. To like idea, but yeah, I'm totally not out for likes, and I toggle all mine that they are not for kids as well. So I'm not even getting the kids because I know they wouldn't, But I feel like a lot of YouTubers target kids because kids will watch videos of 400 times over and over, right? That's how you want to target. If you really want a YouTube channel that takes off, make one for kids. Baby Shark is a perfect example.
Like Melon or something like a fourth largest YouTube channel. Like I've never heard of that.
Because kids just put that on repeat. It is just like babies in front of TVs while their parents are getting crap done. Let's see here. I'm going to swap it out for that for this part that we've just modified. And I'm hoping, this is my plan, that I didn't change any of the machining features like the groove for the O-ring, or the oil seal at all. I should not have to do any constraints once this comes in. But let's just see if I do, because technically I didn't change those features on this. So, oh, the problem is I don't add any what do they call them? Just the little divided segments that are titled through my videos. I need to go back in and add those timestamps so that you could actually know instead of having to peruse through 2 hours of video and mostly be talking about engineering design concepts and nothing that you really want to know. But so I did. I think I swapped it out, right? Yes. And I didn't have to, and it didn't blow up on me at all. And the reason is because the features didn't really change, and I changed the outside of this, but there was that didn't affect any of the constraints with the other parts in the assembly. Those are the features that the parts are constrained to are the same from this part to the other part, and so happy assembly here. Yep, yep, yep. That kind of a thing is what I keep talking about. Like that's why you don't delete lines in sketches and stuff like that. Then that starts to make stuff blow up because it just loses that relationship that you established. It's better to try to modify, delete constraints, change your geometry a little bit, but maintain the sketch geometry. Unless it's just too time consuming, and then yeah, start again, and then just kind of go back and redo all the constraints that maybe have blown up. So this one I'm happy with. This one I just need to now I need to insert this assembly into this assembly here. So here's my master assembly. It's ready for the seal plate there. The seal plate's done. Let's assemble it. Place that thing. And then I'll take a break after I get this placed and constrained in here. So I'll say I need that assembly. It's right here. Open that thing up, and that's going to be for the drive end. Select that, push G on your keyboard to get the little spinny wheel. If that's what I like to do. Spin that thing around, orient it kind of how. Technically, it's one that I'm not super concerned on if it's clocked. It doesn't, it is kind of a symmetrical part. So, you know, and I'm not going to ground and root it. I'm just going to do kind of an insert and yeah. So if I had this oriented backwards from how it was designed, this part, it's not the end of the world on this part because it's symmetrical. For people with real particularness, though, they might want to consider that. So it just depends. But for me, it'll be okay. I'm gonna constrain it with insert, and what's going to insert to me. Remember this little O-ring is going to get squished, so I don't want this to stand off. I pick like here, so I'm inserting this face with this edge and that axis that will show up like that. Yes, I'm going to insert that onto this little edge of the housing here. Those two are going to be face to face through those axes there. Bam. So I'll apply that one. And then the next one I need to do is just clock it. And what I mean is, to me, it doesn't matter if you've rotated this 20 times and you've now forgotten which plane to plane it is. It doesn't really matter. Um, it could matter if we're being real particular. And if I'm building Artemis 3 or something, I'm probably not going to make I'm going to it probably everything matters. I watched a cool video where they were taking the next rocket stages and they were moving them. I mean, they kind of showed the facility because like Artemis 3's like rocket boosters are pretty much like I don't know if they're at the end stage, but they're far along in the fabrication process, and those freaking things are amazing. It makes me want to go work for that whole operation. So, yep, totally. They're squished in there now. Yeah, and we can check that with a half cut view, but exactly right. All the seals are actually sealing. Yep, because what you're doing is you're making a seal between the end plates and this part. And then you're actually making a seal with this part is also making a that oil ring seal to the shaft. And so technically you've kind of sealed this to where things can't get in and things can't get out. I mean, it is only a rubber seal, but um, you're just minimizing things that can weep their way out. Yeah. I mean, technically you're saying like, yeah, that could stuff could weep into here, and it's like, yeah, but it's going to hit that oil seal and not be able to make its way out to start getting into the bearing is what it is. It's protecting I mean, it definitely protects product, but really it's really designed to protect the bearing itself, actually. It just does both. It's the two birds. Oh wait, yeah, two birds with one stone. They gotta change that saying. That's pretty brutal. We need to stop killing birds and I don't know what. Stop killing in general, right? Got to be a better saying. I need to plainly align that thing though. So whatever plane I've got on it, I'll just pick like yeah, like to me I'd pick either these two planes are optional for whichever. So I'll just pick the YZ plane that I'm going to constrain to my origin YZ, and then I'm happy. Either solution should work for that. It shouldn't matter which solution, whether it was flipped. That's done. Dunzo there. Yes, good. It's ready for hardware. Kind of matches. And then yeah, if you want to take cut a half section view here through that again, you'll see that relationship of what's going on um, between this little O-ring. I'll just check that real quick. That little O-ring is getting squished, which is pretty normal. It's designed to squish. And yeah, these are good things to check. I mean, this is a big part of like jobs where even as new drafters, you might be given models, and then they might ask you to go through and check for interferences. This would be that concept of I'm checking for interferences. If I was seeing that the end plate hole is not big enough for the shaft, you know, you'd have to know what you're looking for, but you're definitely constantly checking fits. And I like this. I'm happy with this. Okay, and then I think we can take a break. I'll delete my section view. Call that part one. When I come back, I just need to uh definitely ready to start drawings for this thing now. I'm just gonna do a couple. We're gonna put bolts in. We're gonna open up the housing. So I can go ahead and open up it now. That's the housing model that we've already done prints for. I mean, we kind of have completed this subassembly. Other than I'm gonna make one little change that's gonna affect our drawings. I'm gonna add some bolts to this. The stuff that bolts on here. And I'm gonna maybe have to develop a fastener here for my it's probably time to put in the fasteners to actually hold the bearings up. So let's spend some time after break to do that. Call that good. Definitely take a break.